Hello students, I have come with you with another differentiation, with another video of differentiation. There is some problem. First is that fx is equal to root over x minus 1 plus root over x plus 24 minus 10 into root over x minus 1. You have to differentiate this, that means you have to find f dash x. Now the problem is that if you put it in a form of a minus b whole square, if you put it in a form of a minus b whole square, then this root over will be obsolete. So what we have to do, fx is equal to root over x minus 1 plus root over x minus 1 plus 25. We rewrite this term. That means 24 means 25 minus 1 minus 2 into 5 into root over x minus 1. Then this is equal to root over x minus 1 plus root over x minus 1 whole square plus 5 square minus 2 into 5 into root over x minus 1. You certainly see that this is a form of a square plus b square minus 2ab. A square plus b square minus 2ab. Then what we have to do is that this is a minus b whole square, that means root over x minus 1 plus root over 5 minus root over x minus 1 its whole square. Root over x minus 1 plus 5 minus root over x minus 1, cancelling, we get this is equal to 5. So our f dash x is 0. Now there is a problem. Problem means if we write here root over x minus 1 whole square minus 5, x lies between 1 to 26, then root over x minus 1 minus 5 is less than 0. Is less than 0. That means this will be a imaginary number or complex number. So we cannot put this root over x minus 1 minus 5 whole square. So we write it 5 minus root over x minus 1 whole square. Cancelling, we get 5, and then f dash x is equal to 0. Next problem is fx is equal to e to the power x plus e to the power bx, a not equal to b, and if f double dash x minus 2 f dash x minus 15 fx is equal to 0 for all x, then find the product of ab. So what we have to do is that we have to differentiate fx, then double differentiate fx, then putting the value of f double dash x, f dash x and fx, we will get the required result. So fx means e to the power ax plus e to the power bx. F dash x means a e to the power ax plus b e to the power ax. F double dash x means a square e to the power x plus b square e to the power bx. This is bx, sorry. So putting the value, we get f double dash x minus 2 f dash x minus 15 fx is equal to 0. F double dash x means a square e to the power x plus b square e to the power bx minus 2 f dash x means a e to the power x plus b e to the power bx minus 15 fx means e to the power x plus e to the power bx is equal to 0. Now taking common e to the power x, we get this is a square minus 2a minus 15, and taking common e to the power bx, we get b square minus 2b minus 15 is equal to 0. We know that e to the power x and e to the power bx always not equal to 0. Then the product is 0, so this is 0 and this is 0. So we get a square minus 2a minus 15 is equal to 0, or a square minus 5a plus 3a minus 15 is equal to 0. Taking common, we get a into a minus 5 plus 3 a minus 5 is equal to 0. That means a minus 5 into a plus 3 is equal to 0, or a is equal to 5 or a is equal to minus 3. Similarly, b square minus 2b minus 15, we get same and similar, b is equal to 5 and b is equal to minus 3. So your answer will be a into b is equal to, so AB will be 5 into 5, 25, 5 into minus 3, minus 15, or minus 3 into minus 3 is equal to 9. So in these three values, what will be the answer? Your answer will be minus 15. Why my answer will be minus 15? Because it is given that a not equal to b, e to the power x plus e to the power bx, where a not equal to b. If in this case a is equal to 5, then b is equal to minus 3, or a is equal to minus 3, b is equal to 5. That means a not equal to b. So our required answer is ab is equal to minus 15. That's all. The third problem is, if 2y is equal to x into 1 plus dy dx, then prove that d3y, then prove that d2y dx2 is constant. Sorry, d2y dx2 is constant. What we have to do is that at first we differentiate this 2y is equal to x into 1 plus dy dx. Then next we solve in this way, differentiating with respect to x, we get 2 into dy dx, differentiating x 1 plus dy dx plus x into differentiating 1 means 0 plus d2y dx2. That means 1 plus dy dx plus x d2y dx2. This is 2 dy dx. Now again differentiating we get 2 into d2y dx2 is equal to, differentiating 1 means 0 constant, this is d2y dx2 plus, you differentiate it in UV form, that means x into ddx of d2y dx2 plus differentiating x means 1 into d2y dx2. Now this is d2y dx2, d2y dx2 is equal to 2 d2y dx2 plus x d3y dx3 into 2 d2y dx2. Cancelling, we get x into d3y dx3 is equal to 0, or x not equal to 0, then d3y dx3 is equal to 0, or differentiating we get, this can be written as ddx of d2y, or this can be written as ddx of d2y dx2 is equal to 0. That means, or d of d2y dx2 is equal to 0. Integrating we get d2y dx2 is equal to constant. d2y dx2 is equal to constant. Integrating both sides, we get d2y dx2 is equal to constant. So we get the required result. This is a very easy method. After differentiating 2 times, we get the result. Okay.